Okay, so trig proofs, it's kind of like solving puzzles. If you're good with math and you can see things and you have your algebra steps, trig proofs are okay. If you don't see things and aren't good with your algebra steps, it's going to make it hard. Okay, so I'm going to lay out a few strategies. So these are some of my strategies when I do trig proofs. It's in the notes. It's called trig proofs. No, notes. It's in the same notes book that we've been writing in. Okay, so this chart here is me giving you strategies, but I struggle with anything else but just giving you some strategies, because to me, trig proofs is your instincts. Like when I coach basketball, just instinct, cut to an open space. That's an instinct, okay? So it's hard for me to teach it. You have to rely a little bit on your instincts for it. So here's one strategy I can give you. When you do a trig proof, start on the side that looks more complicated. Substitute. So for instance, what could I replace tan x with? What is tan the same as? Sine over cos. There's a substitution. Here's another example of a substitution. What could I replace secant with?
1 over cos.
1 over cos. Another example of a substitution is what could I replace cos squared with? Maybe something on this paper, maybe something in the top corner, maybe a bunch of things we wrote down. Did you find something?
1 minus sine squared.
1 minus sine squared x. Okay, so some of the substitutions, so tan, the flips, you should just know some of the substitutions will come from these little equations. Another strategy is to do common denominators if you ever have to add fractions. Another strategy is to cancel multipliers and dividers. Splitting the fraction, so maybe this is new for you. Splitting the fraction when I have 1 thing over 2 here, I can split those apart. You see my 1 over sine and my sine over sine. I split them apart. You can factor. What are the common ones you might see? You might see some difference of squares stuff going on. You know how to do that, right? Pros. You might see simple trinomials. What are some other things you might see? Complex trinomials or one other kind. GCF. And one more strategy. You've learned this word in grade 11, conjugate multiplication. So a conjugate, so if you have 1 plus sine x binomial, what's the conjugate? 1 minus sine x, that's a conjugate. So yeah, the opposite. Okay, when I go back up to this one, cancel. You can cancel anything that's multiplying and dividing. You cannot cancel an adder. That is the #1 mistake people do on trig proofs. All the time, and I even preach it, and still people do that. So what do I mean with multipliers, dividers versus adders? Okay, think about this fraction. It would be 9 over 10, right? Here's the mistake people do. They're like, oh, there's a 4 and there's a 4. I'm going to cancel them, right? That's somebody's instinct, which if I canceled, it would produce a 5/6. Is that the same thing? No. So that's why I say canceling adders is a mistake. So this is a mistake. When somebody says, oh, I want to cancel a sign, and then they go like this, and then they take out one of those. Wrong. Can't do it. That's an adder. Do you see it? That's the same mistake as somebody doing that. Versus multipliers, dividers. This is a multiplier divider where this would be 20/24. I can cancel the 4s and get 5/6, which is the same thing. Do you see? Canceling the 4s here is allowed. Canceling the 4s here is not allowed. Do I have to make you do an oath that you're promising me to never cancel an adder? Put your right hand in the air. I will not, repeat after me, I will not ever cancel with adders. I'm telling you, your instincts, try to go there. Just avoid those instincts.
I guarantee you're going to do it.
60% of people do it. I don't know why. It's always somebody's instinct. Be the minority. Avoid that instinct. Don't go there. Okay, here we go. I'm going to start you super simple. Which side would you want to go to? Start this side or this side? More complicated. So this side looks more complicated. What do you have? Can you do any substitutions, fractions? What do you have? You would do a substitution for tan. Okay? So tan is the same as doing a sine theta over a cos theta. I can cancel, because they're multipliers, I can cancel that and I get sine theta and I'm done. Why am I done? Because this side now looks the same as that side. You are not ever allowed to write an equal sign. If you ever put an equal sign in there, you lose half of 3 points, you lose half of a point just by putting an equal sign in there. So at the end, you make a conclusion. You can either go, I made the left-hand side equal the right-hand side. You can say that. Or you can do the Latin, QED.
Quod erat demonstrandum.
So that's where you heard me playing that sound. I wanted to see how to pronounce it. QED in Latin. That's what it is. Quod erat demonstratum. What do you think it means? Look at me, I demonstrated it. That's all. It's kind of fun. QED. Okay. Don't worry, you'll never get one that easy. Okay, a little harder. Which side do you want to tackle? Which one looks harder? This one? So I'm going to probably think about substitutions again. So secant, I'm going to replace secant with a flipped cos. So there's me replacing cos, or secant. I'm going to replace cosecant with 1 over sine. So I substituted secant, I substituted cosecant. Two fractions, can you rewrite a times flip situation? And you're going to have to go one more step here. You can either go one more step to turn that to tan, or you could go on this side and turn tan into a, okay, it doesn't matter. You could go from that side one step, or you could have gone underneath this and put a tan. I did it. I just showed you. No equal signs. I'm just trying to show you.
What if you don't write that?
It's just like your summary at the end. Like,
You'll get it right.
yeah, it's fine. Okay. Which side is your instinct pointing you towards? This side, yeah. Okay. When I look at all these and I kind of peek over to the other side, there's just coses and sines. So could you do some substitutions here that end up with just anything with coses and sines? So how do you write cotangent with coses and sines? So cotangent is an x over a y, so x is a cos. So cos and a sine. And what would you replace tan with? Okay, now I see two fractions. What do you do when you add fractions together? You make them one fraction together by using a common denominator. So what should I all put inside my denominator? I need a sine x in there and a cos x. Just like if numbers were here, if like that was a 4 and that was a 7, you'd have to put a 28, right? You'd need them both. Okay, we kind of did this work in grade 11. Look at the bottom, look at the new bottom. What happened? From here to here, what did you do? You times it by cos. So what are you going to do to the top? Times also by a cos. What would we call this together right here? Cos squared x. Does everybody know cos squared x is the way to write it? Cos x squared is something completely different. Okay, so fraction 2. Look at the bottom, look at the new bottom. What changed? Sine x, we times it by sine x, so therefore we should also times the top by sine x. Does anybody see something from maybe the top corner of their sheet? In the top corner. Any findings in that little top corner stuff that we wrote all about? This on your formula sheet is equal to 1. So you can put 1 on the top. And then you're done. Okay, what's your instinct saying to go on, the left or the right? The left. Okay, I'm going to peek on the right though here. Do you notice that the only thing I really have left is with signs in it? This is kind of like a sign left. So on this side, I don't see anything dealing with cos anymore. Somehow the cos is gone. So can you look at this cos stuff? The cos squared. Would you have a replacement for cos squared? Top corner. find something from the corner, replace cos squared with. Okay. Please tell me no one had an instinct to cancel here. That was not happening, right? You thought about it, but then you remembered to fight that urge to not cancel these adders. Don't do it. Okay. One of the different strategies, so there's that little chart I had. Can anybody pick out a strategy? Well, substitution, we just did something with that. Is there any fractions to add? Canceling, splitting, factoring, conjugate. One of these is the answer to go to. It's not a conjugate. One of the things in my chart. Substitute, well, we already did something with that. Can you add, subtract fractions with common denominators? Can you cancel anything? No. Those are adders. Split the fraction? No, I can't because I have multiple bottoms. You can only split a fraction with one denominator. Can you factor anything? Yes, you can factor. What is that top stuff? What's the style of it? Factoring. Difference of squares. Okay, that's a difference of squares. So how do you do a factor of difference of squares? 1 times 1 plus minus sine x. That's a difference of squares, right? Can you factor the bottom? Yes. What's the style called on the bottom? It's a GCF. So there's two terms. What do they both have in common? So sine x bracket. Sine x times what makes that? 1. Sine x times what makes that? Now what? You can. It's legal now. You can cancel now because everything's set up this times this, divide by this times this. So that. Okay. What's that? No, do not. Do not fight those instincts. Do not cancel those. Okay.
I know you want to do it. I didn't think of it.
I'm going to give you
I know you thought of it.
I'm going to give you two options to finish this out on your own. You could this. That's called the split. You could split those apart now. Or you could go from the other side and do stuff. Do you want to, so what do you want to do? Do you want to split these up? Or go to the other side? Go to the other side? Okay, so then I'm going to replace cosecant with a flip of sine. How do you add stuff with fractions involved? You put them together as one with a bottom that you can use for both. So I'd have to turn everything into sine x bottom. So this bottom was really a 1 before. So now what would you have to do to the top? Sine x. This bottom was sine x. So I just leave it. And you're done. Okay, that's the same. I know it's just flipped around like that, but that's the same.